All right, so we're going to look at another check-in for Unit 6. And today we're going to be looking at completing the square and then a few simplification problems that are going to be useful for today and tomorrow. So looking at this first one, completing the square. Okay, remember our goal is to make something with the parentheses squared equals a chunk. That way we can take the square root and solve it. So that's going to be our goal. So to do that, we're going to start by getting rid of actually before we can do that, we notice that 2, 8, and 4 all have a greatest common factor. So that means we're going to start by dividing out the greatest common factor, which is 2. When we do that, the 2's cancel out, so we'll just have x squared. 8 divided by 2 gives me plus 4x. Negative 4 divided by 2 gives me negative 2 is equal to 0. Now I can go through my completing the square steps. So we're going to start by adding the 2 over. That will cancel out, and we'll have x squared plus 4x is equal to 2. Now is when we have to add in our new c value so we can add it to both sides. So to do that, we're going to have our b over 2 squared equation. So our b value is a 4. So we're going to have 4 divided by 2 squared. 4 divided by 2 gives me 2 squared. Remember that 2 is going to be that special number that we're going to need. And then 2 squared gives me 4. So that's going to be our new c value, and we're going to add it to both sides of my equation. So I'm going to have x squared plus 4x plus 4 is equal to 2 plus 4. So now I can factor the left side of my equation. So I need to think what's going to add to give me 4, but multiply to give me 4. Okay, well that's going to be that number in our parentheses, the 2. So 2 plus 2 gives me 4, and 2 times 2 gives me 4. So I'll have x plus 2 squared. Remember, we can go ahead and start writing it as x plus 2 squared is equal to 6, because 2 plus 4 gives me the 6. Now, that matches what we said our goal was. Okay, so I'm going to move this on up here, and we're going to finish the problem. X plus 2 squared is equal to 6. Okay, so that was our goal, so we could take the square root of both sides. The square root and the square root cancel each other out, so I'll have x plus 2 equals, I cannot reduce the square root of 6, so I just write it as plus or minus the square root of 6. Okay, and then last step, we're going to subtract the 2 over, so I'll have x is equal to negative 2 plus or minus the square root of 6. We have to put that in our solution set, our curly brackets, and then we're done. So I know this feels like a lot of steps, okay, but these are all things that we've done, okay, and remember, once you get the hang of it, you can start skipping some of those non-essential steps, okay? It's just going to take some practice. Alrighty. So looking at the next section, we're just going to practice simplifying stuff. It's just remembering our order of operations, okay, and it's going to be really important for today and tomorrow. So remember, our order of operations are PEMDAS. Okay, so we're going to start by simplifying this. Okay, the first thing is parentheses, but if I look inside these parentheses, I can't simplify that at all. Okay, so we're just going to worry about simplifying what's underneath the radical. Okay, our next one is going to be exponents. So we're going to deal with our exponent. Negative 2 squared gives me 4, minus 4 times 3 times negative 5. Next, we have multiplication and division. So I'm going to multiply or divide anything I can. So the 4 just hangs out. Negative 4 times 3 gives me negative 12, times negative 5 again gives me positive 60. Okay, remember you can put that in the calculator. Negative 4 times 3 gives me negative 12, times negative 5 gives me a positive 60. Why we have the plus 60 there. Next comes addition and subtraction. So we're going to add 4 plus 60 gives me 64. And then we know that the square root of 64 is 8, but we're in our quadratic unit, so we're going to be used to writing it as plus or minus 8. Okay. All right. So the rest of these are very similar. Notice that the radical looks the exact same on every single one of these problems, okay? So we're going to get used to doing this a lot. All right, so look at this one. We're going to deal with what's underneath the radical first, okay? So that means we're going to deal with our exponents because I can't do anything to the parentheses. So we're just going to deal with our exponents. So I'll have 4. Notice the plus or minus, okay? That's going to come in handy, just like we've been dealing with the plus or minuses. The square root. Negative 4 squared will give me positive 16 minus 4 times negative 2 times 4 all over 2 times negative 2. So then we'll have 4 plus or minus the square root. Now we're going to multiply all these pieces together. So I have 16. Negative 4 times a negative 2 gives me a positive 8 times 4 gives me plus 32. All over 2 times negative 2 gives me negative 4. Now we get to add our stuff together. So I have 4 plus or minus the square root. 16 plus 32 gives me 48 divided by a negative 4. Okay, we're just simplifying the radical. Now we have to deal with with our radical now. We have to simplify the radical. So remember, 48, we look for the largest perfect square that goes into 48. You might be thinking it's 4, but it's not actually 4. It's going to be 16. So it's going to be 16 times 3. And the square root of 16 is 4 square roots of 3. So we can simplify this as 4 plus or minus 4 square roots of 3, all divided by negative 4. And then, guys, you can simplify it one more time because remember, you always have to reduce fractions. So 4 divided by negative 4 gives me negative 1 plus or minus 4 divided by negative 4 gives me 1 square root. So 1 square root of 3. And that's what's going to go into my solution set. I know that feels like a lot of steps, but that's why we're practicing that simplification. So, because it's the same process every time, so it's just we got to get used to that. All right, looking at the next one, we got negative 5 plus or minus the square root. We're going to deal with our radical first. So 5 squared gives me 25. And then, guys, you can go ahead and multiply the right side all in the same step. So negative 4 times 1 gives me negative 4 times 4 gives me negative 16 all over 2 times 1. And we're just going to keep simplifying. So I have negative 5 plus or minus the square root. 25 minus 16 gives me 9 all over 2 times 1 gives me 2. So we'll have simplified again. Negative 5 plus or minus the square root of 9 is 3 all over 2. And guys, this is where we have to write this as 2 separate problems, just like we have been with the plus or minus. So we'll have negative 5 plus 3 divided by 2, and then negative 5 minus 3 divided by 2. So negative 5 plus 3 gives me negative 2 over 2. Oops. And negative 2 divided by 2 gives me negative 1. And then negative 5 minus 3 gives me negative 8 divided by 2, which is negative 4. So my solutions are going to be negative 4 and negative 1. Fun stuff. Alrighty, last but not least, we have 3 plus or minus the square root of negative 3 squared minus 4 times 8 times 2 all over 2 times 8. So we'll have 3 plus or minus the square root. We have to do our exponents first because of our PEMDAS. So negative 3 squared gives me 9 minus, we're going to go ahead and multiply all this stuff together too. 4 times 8 gives me 32 times 2 gives me 64. So minus 64 all over 2 times 8 is 16. We're going to keep simplifying. So I'll have 3 plus or minus the square root. 9 minus 64 gives me negative 56. Not 56, sorry, negative 55 all over 16. And guys, if you were to put negative 55 into the calculator, or not negative 55, if you were to put the square root of negative 55 into the calculator, it would give you an error. Anytime that there is a negative underneath the radical, okay, or so anytime it tries to take the square root of what's underneath the radical, that is not possible. So that means we're going to have no real solutions. So that means if we were to graph this, that means it's never going to hit the x-axis. So if we were to graph it, it would look like this. So it gets close to the x-axis, but it never actually touches it. If it never touches the x-axis, that means it's no real solutions. Alrighty. If you have any questions about that, please make sure you're asking. Okay, and then you can move on to your notes.